What you guys are seeing here is 500 cars, all moving, all along splines, and running at 120 FPS, assuming I don't move my mouse because editor stuff. But as long as I'm actually running just the thing, it's a relatively stable 120 FPS. What you also have to keep in mind is while running 2 Unreal Engines and OBS and everything else. So it's relatively good. And the reason I'm simulating and not playing is just so I can show you guys that if I fly all the way to the end here, the way we're achieving this is we're making it so the cars just update so much less often the further back they are. So we've improved the updates based on distance. The ones closer here update more frequently because that is where the character is. In fact, I can go right into the actual game and play. And now if I was to go up, and we can see here, there we go. Up here, solid, and you can see all the way down there, the cars are still moving. They're just moving a bit less. And by less, I just mean less often. And I've actually set up a way of being able to still have this not break, which was important to me, if you had a major lag spike. Because one concern I had immediately was, if you're playing right now, and it's saying right now in the top right, 120 FPS, but if I just click out of Unreal, I'm at 3 FPS, right? It's not actually running this at 3 FPS, but it was, as far as Unreal is concerned, not in focus, so it does the unfocused thing. But you can see here, despite me going outside of there, what it does is basically freeze everything. It stops everything from updating until we get back, and then we just continue as we were. This way, even if you have a major lag spike, something happens, and your performance really tanks for a moment, that's okay. It should not break the system, which is kind of important. We'll be fixing up a few things and making it a lot more performant in today's next part of the tutorial series. So let's get started. So this is the current setup that we have, and while it's good, it does have a slight issue of occasionally cars not finding the path. And as you saw there, we had a few run a red light. This one's off of the spline. It's not perfect. There's occasionally it does have issues. And the way I figured to fix this is by checking the distance to the destination point. If the distance is getting smaller, we're clearly coming up to that spline where we need to do the swap off to the next spline. But if it starts to get bigger again, so it's growing, we've missed it. And if that happens, assign it, put it on the spline. Nope, we're not missing it. We're not missing it. We found it. It is successfully finding it. Is just the placement of the car, depending on the kind of the updates, might not be close enough. And this also will get around the potential problem of us changing the frame rate of the cars while they're moving. So let's go ahead and adjust for that. And we're going to be doing that on the car blueprint again, where we have the set current spline component. Basically, we need to add a little bit of a logic here to say, hey, if we're now passing it, assign it. So let's just go ahead and I'll move this a little bit to the side and we'll give a bit more room to work here. So the first thing I actually want to do is make sure this only triggers once. So I'll just drag out of here and do a do once. And we'll go ahead and reset it once we've assigned the actual spline. And the other thing is I want to do the rotation that we were doing down here. When we were doing the one trace for new path, we were setting the rotation. So I want to still do that. So I'm actually going to copy this and put it here. And I'll plug this in right after the do one. So we're basically setting the actual rotation to face the spline, just like we were doing before. The start is going to be the actor location, and the target is going to be this world position of the hit component as we were doing before. In fact, we'll just reorder these two around so that way we can just reuse this because we're just doing a distance vector. The order of these two don't matter for this node. So basically we have put in this rotation here, just like we were doing when we were doing the trace for a new path. Then we're still checking that if we're within a certain distance, but right now we were multiplying by 2. We're going to remove that. So now we're doing it just on the current speed to see if we're within the range. So that way we don't have a snap potentially. But I guess in a sense, we're going to make it snap if it goes over. So in some little aspects, there is going to be a slight snap. Not always though. And then there's this check, right? This is the one that checks, hey, are we kind of in range every time? And this is where we're going to add a little bit of extra logic. And for the logic, we actually need a new variable. I want to know the current distance to path. How far are we to the current path? I'm going to set that to be of a type float. I'll go ahead and compile it, and I'll set the default distance to path to be extremely high. Basically, whatever distance will be there the first time will be less than this. So we'll overwrite it. And the way we do that is from false, we will check that the distance to path, if the distance, the one that is between us and the goal, is that vector distance greater than the distance to the path. Because if it's getting bigger, that means we're moving away from it. It should always be getting smaller otherwise. So we'll just use a branch here, and off of this false, instead of going to the delay, we'll go in here and then say, okay, false, we are still getting closer. It is still smaller than the current distance. And if it is, what is the new distance? So we'll just, off of false, set the distance to path to be this distance vector. There you go. I've kind of reorganized it so it'll be easier to see. And after we've set this, we want to, of course, wait, as we were doing before, based on whatever the frame rate is. And after we have waited, we will check again, are we now closer still or not? But in this scenario where this went to false and we are now getting further away from it, we are going off of true. And all I want to do is check that first the spline is valid, because it's kind of important. So I'll grab the current follow spline, and then I'll right click and convert to validate get. Hey, is it valid? And it shouldn't be at this point, because we should have already gone off the current spline. So if it's not valid, then we want to go here and set the new spline. If it is still valid, that means we triggered this before we actually finished going on the current one. And if that's the case, just continue here back onto the distance path, continue tracking it and waiting until this stops being valid. This is kind of more of a safety thing, where if for some reason your current spline that you're traveling along goes past the start of the next one, so your kind of spline is overshooting it, it'll still keep track of it. It will snap it back though, but at least it won't completely break. Normally you shouldn't have any kind of like overlapping splines where you go from one to the other, but this is just an in case thing. So great, we're going to assign the current false spline now, but we also need to now set the distance to path to be back to that very large number. So I'll go ahead and do the set here and just set it back to be some very large number. It probably doesn't need to be this big. It just needs to be way too big for it to ever mistake itself. And of course, after we do this, we need to say, okay, go ahead and reset this. So we'll just drag from here all the way to the start to the reset and just reorganize this a little bit. So there we go. So that's our new kind of setup here. We're making sure it's close enough. And if we overshoot it, then it will still assign it. Looking good. But since we're already setting this up and so similar to this, let's just reuse this system down here. The only thing we're doing differently is how we're tracing. So all we need to do here is just run the set current spline component down here now. So right click, set current spline component. We'll go ahead and call that. Hit component goes to hit component. Hit actor goes to spline actor. And then we can pretty much get rid of basically all of this. Just get rid of all of it and do this off of true. And then afterwards, we can just plug this in here. So there we go. We're just going to be reusing the same system because no reason to have it here twice now. Okay, so let's go ahead and simulate now and see if there's any cars that do not find a spline at any point, or do not follow it, or have any kind of intersection issues. Obviously, we'll still have could not find new spline on the one that kind of exit out, but now no car should ever kind of go when they're not supposed to, or into a lane they're not supposed to. It should pretty much now be completely solved, which is pretty good. As you can see, none of these had any issues. And there you see that one snapped just a little bit as it got onto the spline. We'll go ahead and run it one more time just so you can see that it is now actually working all fine. There we go. These guys are stopped. Next ones are going to go. And again, no issues whatsoever. We have finally fixed this perfectly. Now, the car still will stop suddenly when they reach a red light. That is something for me to adjust later. We'll be adding in yellow light functionality and things of that nature. And one thing at a time, though. We're making progress, which is important. So there we go. So now we're all good. The next thing I want to fix is the fact that sometimes cars get left behind. So when a car starts to drive forward as the one behind it kind of stops, the timing of it could theoretically result in a scenario where the car behind just never ends up going forward. So we want to fix that. The thing we were doing before is tracing kind of a single line top down where the car was behind. The problem with this is it doesn't account for potentially cars just at the last moment approaching, and it doesn't account for potentially having a curve on the road where the car kind of comes in at an angle. So you might overshoot or undershoot it. Let's adjust this to instead do a sphere trace from the car back. And we'll give it a little bit of a radius, which will account for a little bit of that angle change. The main logic of this will be similar. The difference is I'm going to use a sphere trace for objects. We want to do the regular one, not the multi. The start location will be ourselves. So we'll do get actor location, and we'll plug that in as the start, and we'll trace back. So go ahead and grab the get actor forward vector to know which way it's facing, and we want to trace a certain distance back. I'm going to trace it 2,000 units back. So I'm going to right click on this vector to convert it to a float, and I'm going to say, okay, trace back 2,000 units, and by putting it as negative is going to be, instead of forward, it'll be basically reverse. So 2,000 units back based off of our current location. So we add it to the current location, and that becomes the end here. The vehicle is still what we're tracing, so I just move that over for the object type, kind of move this down. And we still want to ignore self. We don't want to trigger on ourselves here. Then we can go ahead and change these over. If you hold control, by the way, if you didn't know, you can just click and move these from one to the other. So now we can go ahead and get rid of this and move this one up and reconnect it. So pretty much the same kind of logic for making the car behind drive, but now is doing a sphere trace. And let's go ahead and give it a radius of something like 200. This is just so we can have a bit of leeway, whether it's turning in or out or straight behind us. The other thing is 1 to 1.5 seconds is a bit long. Let's go ahead and make it between 0.5 and 1 second. The rest of this is fine. But the other thing is, aside from actually needing to comment this, we're currently doing this when we're saying drive. But what if the car never stopped? What if it was just slowing down and then we told it, hey, drive, as in continue and accelerate, but you're already driving. So instead, what we just told you is to accelerate. So let's move this logic to trigger off of acceleration, not specifically driving from a full stop, which also makes sense because when your car starts to accelerate, you want to tell the car behind it, like, hey, car ahead is going faster. Go ahead, accelerate. So I'll just go ahead and Control X to move it from here, and I'll move it to this acceleration section. And after this timer, we'll go ahead and say, okay, make the car behind drive. And while we're here, we are setting acceleration. So when this happens, we want to make sure that deceleration is not going. So we have the deceleration below with the stop car timer. Let's go ahead and grab it, get stop car timer, and we'll just do a clear and validate timer by handle. So basically, if we're for whatever reason saying accelerate, well then definitely stop decelerating. We don't want these conflicting. This is just so if you're starting to decelerate, right, you're slowing down, also the car head starts going. If we just told it to accelerate without stopping the deceleration, it would kind of fight each other, and we have issues. In that same sense, when we're decelerating, we're currently stopping the drive forward timer once we hit 0 on our speed, but we're not stopping the acceleration timer, which is separate. So let's go ahead and stop both. I'll potentially need to do this in multiple places, so I'll just select both of these, right click, collapse to a function, and I'll call it stop driving timers. Because we'll stop multiple of them here, and in here, we're stopping the drive forward timer, and we just need to get the acceleration timer as well, and also stop that, just like so. So now, once it actually gets to 0, it can go ahead and stop. Now, when it's decelerating, because of how the deceleration works, we get slower and slower deceleration as we get to the goal in terms of the distance covered, right? As you get closer, you're slowing down. And basically, at a certain point, you're effectively not moving, but technically, you're still moving a tiny amount. So because of that, I want to give a little bit of leeway. So that way, let's say within 5 units, it'll just say, you're close enough. We don't need to be perfectly at 0, and then it'll just stop or get to that speed. So all we need to do is see if this deceleration goal plus our kind of range here, we'll say +5, and then just swap the inputs here for visual flow. Check within deceleration goal +5. Effectively, let's say we're going at 100 and the deceleration goal is at 0. Once we're going at 5 speed, we're going to say, oh yeah, that's close enough. Go ahead and set it to 0. Same thing if we're decelerating to 20. We're at 25. We'll say just set it to be 20. The number is small enough that you don't visually notice it. You can, of course, play with this number as well. But this just prevents things that you don't visually see, but technically it's still computing under the hood. And because we're at that point setting it to be the speed, we can maintain this one as less or equal to 0 to stop the acceleration timers here. Again, if we take a look now, you can see that all the cars should still come to a stop just as we were doing before. And you really cannot tell that they're slowing down and then just hard stopping. Of course, when they get here, they're going to have that issue, but we're going to set up a yellow light here. But as you can see, the ones later on have no issues, and you can see they're still speeding up just fine. Again, yellow light thing that will add up later. Next up on the topic of kind of not doing things when we don't need to, the tracing for the car ahead in general. Right now, on the drive forward function, we're doing trace for car regardless of whether or not we're following the spline or not. And this is based off of our update time. But we really don't need to know the car's info that often. We can get away with a lot less. So I'm not going to use the trace for car here. I'll be removing it from the top and the bottom section, and instead we'll do it when we say drive. So after we start the acceleration, just move this over, and we'll create a new timer. So let's grab the set timer by function name, we'll just duplicate it over for convenience, and instead of drive forward, it's the trace for car. So we'll go ahead and copy it and paste it as the name, and I want to do it every 0.1 seconds and maximum once per frame. And of course, we'll need to know this timer, so I'll go to right click, promote to variable, and I'll call it the trace for car timer. So only go ahead and do this every 0.1 seconds and maximum once per frame. Now that does also mean that we do now stop this timer whenever we stop the car. And we're doing that here. When we decelerate and we stop the car here, stop driving timers, we're stopping the drive forward, the acceleration, and now we're also going to take the trace for car timer and also stop it as well. Again, make sure all of these timers are off. There's no reason to check for the car ahead because we're not moving. Go ahead and just stop it. And obviously, if it never stopped fully, it'll just continue checking the cars ahead as it was before, but now only 10 times a second. And for my testing, that was enough. Again, we'll go ahead and just play this, and you'll see that, yeah, everything should still, again, work as it was before. It'll detect all the cars and stop detecting them. In fact, let's go ahead and turn on the trace for car. We'll set it to be for duration, and we'll set it to be draw time of 0.1 seconds, because that's how long the timer is. You can see here, right, it's updating. It looks like it's spazzing because it's only updating 0.1 seconds. So this is working real well, and they're all continuing to go as they need to in all their lanes. Awesome. Now comes the big change that I want to do, which is I want to make it so cars do not update as often the further they are from the character. So that way, only the ones nearby are going the full frame rate, and the ones in the back, they can go like 10 frames a second. They don't need to move that much. They don't need to update constantly. So you can have the ones in the foreground be nice and fluid without having to load as much stuff. And also, let's go ahead and set up the lag spike. Effectively, what we're going to be doing is saying, hey, if the current frame took longer than 1/10 of a second, pause. Don't do anything. Don't move the car. Don't move the intersections. Don't update anything. Just hold off and wait till the actual update is now better than 10 frames a second. To do that, we'll basically be modifying this get frame rate to change the update when it goes ahead and launches. Now, we want to turn on the max once per frame now, so let's get to turn that on, which will help a lot. And then in the get frame rate, right now we're just using the update frame rate and the 1 divided by to get effectively the time of the timer to simulate that frame rate. But now we want to know the distance. So I'm going to right click and get player pawn. And from here, I want to know the location of the player. And I want to know its location relative to the location of this car. So we'll just use a distance vector here. And now we know the distance between one and the other. Now, for this, I can't speak on multiplayer. I don't know how to set up multiplayer. So I will leave it to the experts on the multiplayer side of how this should be adjusted for that. If you're a multiplayer expert, let us know in the comments below how this would need to change the system to accommodate that as well. In the meantime, I'll be setting it up from single player. Either way, once we have the distance, we can just give it a kind of a range. So from here, we can just drag out and do a map range clamped. So basically, it'll take an input and an output, and based on where this value falls in this range, it'll output this range. So let's say within 5,000 units and 50,000 units is the range. 50,000 units is quite far, to be honest. But for now, we'll go ahead and set that up. So basically, it's going to go from 0 to 0, which we don't want. We want it to go from our full frame rate when we're within 5,000, because it is clamped. 5,000 or less will be outputting outrange A. And at worst case scenario, when we're this far away, output 10 frames. 10 frames a second is what I want. So instead of having the update frame rate going here, we now have this going in. But I also want to check it against the current delta time in general, because if there's a lag spike, I want to know. So what we need to do is just right click, get world delta seconds. This is basically the delta time. How long has it been since the last frame? And give me the max between these, max float. Whichever one's higher, let me know that. So that way, if there's a lag spike, and let's say this returns 1 full second, it will take this number instead of all of this. So we'll know, hey, a little bit high. So let's go ahead and go back to this drive function. Now we can go ahead and check this frame rate. And we can see, is it less than 0.1? Because again, we said to be 10. 1 divided by 10 here is 0.1. So if it is less than 0.1, that means everything is fine. We're updating. We're not having a lag spike. Go ahead and just continue as you were. But if we're having a lag spike false, go ahead and just wait 0.1 seconds and then try again. Because again, 0.1 is the minimum amount of time that we're actually allowing it to take for this entire timer system. But this is just the starting of it, right? This is what happens when we start driving. Make sure the frame rate is consistent. What about if we're already driving? Well, now in the acceleration, I want to know, hey, are we going the right frame rate? So off of this acceleration here, we can go ahead and get the frame rate, just like before, use the get frame rate, and check again, is it greater than 0.1? And as long as it is not greater than 0.1, we'll go ahead and continue as we were, because that means the frame rate here is just fine. And of course, same thing for the deceleration. Stop decelerating if we are actually above, again, 0.1. If this is false, then we continue on. Because if we have a lag spike, basically stop accelerating and stop decelerating. Now, we might just be driving. So that means that also in the drive forward function, we also want to check that we have the right frame rate. So we'll do again the same thing. Check that our frame rate is not above the number that we need. So basically, stop driving forward entirely, stop accelerating, stop doing anything if we're having a lag spike. Let's see what happens now if we go ahead and play. We can zoom out. So these guys are updating. I'll go ahead and click out of Unreal. It's all stopped. Now, the intersection is continuing to update. We have not told it to stop yet. So that's one thing. But if I click back in, the cars will just resume basically what they were doing. So obviously issue with the intersections of those cars going, but now we need to just update the intersection to also effectively stop doing things, stop updating until we resolve this lag spike. So here we are in the intersection blueprint. This is where we're telling it to go ahead and do the stop, do this drive, all good. It's also set to max once per frame, which is great already, but we need to change this next traffic light because we don't want to do this if we basically should stop. So just like the other ones, we're getting the frame rate and we're checking it. The difference is we're not using the frame rate here, we're just using the delta time. So we're doing get world delta seconds because we just need to check for the actual lag spikes only. And we're checking it if it is greater than 0.1. Are we having a lag spike? So if we are or not, we go ahead and set up a branch. If we are having a lag spike, I want to actually pause this. I don't want it to continue to update. So I'll just move this out of the way and I'll promote this to a variable. Right click, promote to variable. I'll just call it traffic light timer. And then it'll go ahead and be set here. And then down here, we could say, grab the traffic light timer and then go ahead and pause timer by handle. So it'll go ahead and pause it so it won't continue running. And then I want to give it a moment and then check again. So here I'm going to do a delay. Instead of doing a 0.1 second delay like I've been doing here, I'll do a 0.5 second delay. I'm giving a little bit of extra leeway here so that way the cars that were potentially going will be able to finish the intersection, any movements they were doing and kind of get out of the way before it starts to update again. So after half a second, go ahead and check, hey, are we still having a lag spike? And if we're not, if we're no longer having a lag spike, go ahead and unpause timer by handle off of this false, and then continue doing what you were going to be doing before. So this is the full thing. If there's a lag spike, pause the timer, wait half a second, check if we're good. If we are, unpause it and continue on. Let's go ahead and take a look. I'll go ahead, play, fly up so we can see it all. And then I'll just click out and you'll see that all the cars are stopped. Nothing's changing here in the intersection. I'll go ahead and click back in. Okay, that is looking good. And now we're continuing as just fine. Now, one thing to note here is when I go ahead and pause it and then fly out. So we'll go again up here, pause it. We are still checking for the cars ahead, and there's really no need to do that, right? We can just stop doing this trace here. So back in the car base here, when we're doing the trace for car, in here, we're only doing this specifically when the frame rate's good. So again, just like the other ones, get the frame rate greater than 1, branch, copy it, and put it in the trace for car, again, under false here. We only do this when we're not having lag spikes. And now once again, I'll hit play, fly up. Let's take a look at this. We'll give it a moment for them to run so we can see how this works. Then I'll click out so everything is paused. They're not doing traces anymore. Those visual aspects of it have reset. It's not doing any other ones at the intersections. Everything has stopped. I click back in and it continues as it was. Now, obviously, if that car said that was a green light at that moment, then it goes ahead and still goes on it, which is why we had it at half a second. So that way, if a car was about to cross or started to cross, and then it goes ahead and updates it, just let it finish, let it carry on its way, and then we can continue moving the next ones. I'm a little lenient in the potential issues of like slightly overlapping happening during a lag spike with the intersection because it's a lag spike. It shouldn't be happening in general. If it is, we have slight issues. And because I forgot to do it, you want to do on the deceleration, turn on max once per frame here, as well as in the acceleration, turn on max once per frame here. Basically, any timer, we're now running max once per frame. So absolutely every single one of them, make sure this is on. And I've gone ahead and updated the cars here. I've given it more track. I've also given it ways of turning. So that way they don't always end up in the exact same 2 lanes. Now I'm gonna go ahead and hit play. We can go ahead and fly up and see it all in action. And again, the frame rate is going to be dependent on the player's position, which is awesome. And these guys should continue on their path, going all the way around, stopping as they need to. You can see here, it's all going well. And anytime I can go ahead and just click away, everything gets paused, give it a moment, and then click back in. And then the kind of the last cars that were on a green before still go in green. And it gives us the moment of leeway to get back and continue on, as you can see here. So just like that, we have kind of improved quite a few things. And of course, as you saw in the beginning, if I was to fly away quite far, they basically slow down. It's still not a flawless system. I wish I could say it was, but every time we make progress and we improve more things. And by the way, I am aware that I've set up a kind of like a American normal intersection here. And I know a lot of you guys want to see a roundabout. That is potentially what I'll be looking into next, if I can figure out a good way of doing it. Because the main thing with that is we need to check if a car is just driving in a section entirely and if there's room for it to merge in. So I'll see if I can figure out a method with this system. In the meantime, though, the project files for this are available on my Patreon, where you can join these wonderful people here in supporting what I do. It really means a lot. And if you'd like to join the community, the link to the Discord and everything else is down in the description below, as always. And if creating a city itself is more your style, don't worry, I have a series for you just for that.